Hello guys, welcome back to another video. Today we will train our own object detection model to detect our own custom objects in an image, which can whatever you want to have, maybe my glasses, my nose, my watch, something like that, a t-shirt. We can train our own model to predict certain classes, and today that is what we're gonna do. For this, we first need a class that we actually want to detect. I guess you have already your class in mind. For me, I decided to go for football, or some people would maybe call it a soccer ball. I'm not sure. For me, it's like a football. Then we need to label those images that we have. I will show you later the details about it. Then next we will create labels for the images that we got. So we need like bounding boxes around that specific object we want to learn to detect. Then we will create a dataset out of that, which consists of the images and the labels, and upload it to our Colab Notebook. And then we will train our model using our custom dataset. For that we will use the YOLOv7, like version 7 model, and train it with our custom dataset that we created previously. And finally, we will use our trained model to detect our object in new images or in videos. You can feel free, you have generate your model so you can use it in whatever scenario you want to have it. Okay, as a first step, we actually need data to be able to train our model. And for that, since I didn't have any images on my computer of footballs, I had to look them up. I used Pixabay as a website for that. They provide stunning free images and royalty-free stock. So that sounds, really good for me. So now I just type in football and let's see what we get here. I like this image. Try to find a little bit of consistency, so like a green background. Since I won't create like a dataset with more than 100 pictures, I will just create like 10 to 20 images. And for that I try to have them not too variable, like they're kind of consistent in the green background, and in the front you will see a football. So I try to get those pictures like this one. Just go through. Feel free to pick whatever object you want to detect and try to find pictures here. Pretty sure there are also other websites than Pixabay. I just used this one, and I think that's provided everything I needed to be able to train my model. So now I've downloaded all my 20 images of footballs. I can just quickly show them to you. As you can see, I try to have the green grass as a background and the white ball in the foreground in all the images, so the variability of those images is not too big. This way I hope that the model is able to learn, even though it's just like 15 training images that we will have to learn how to detect such a football. And actually I'm quite confident that the model will be able to do that. But let's progress and let's see how good the model will afterwards detect the individual footballs in those images. Now that we have our images, we will now label them to let the model learn how to draw those bounding boxes around the football. So here you can see like how it maybe will look like. You have like this bounding box around the football later. We will use Label Studio for that. So if you're familiar with Python and Python environments, feel free to check out the quick start. You can see you could just using pip install Label Studio on your local computer and start the Label Studio from there. So you will keep all your data local and can label all the images on your local computer. But since I'm not sure if everybody is familiar with Python environments and I want to make this video useful for as many people as possible, I will use in this video the cloud version, where I will now sign up and then show you how to label your images. I had to use my Gmail email address because my other one during sign up it stated that is not an organizational email address, so I had to change it. Just keep that in mind in case you have a similar issue with that. And now we will create a project. Just call it, sandbox is fine. I will call it object detection. And okay, go to import, that sounds good. And now we will import all the football images, which you can see here. It's now uploading them. Okay, perfect. Now all images are uploaded. I import them. And now we have an overview of our all images. What we now have to do is to... Okay, we first have to set up a label interface, as it seems. Maybe let's look into... Okay, yeah. So that's perfect for us, object detection with bounding boxes. And so what I will do, I mean, like, this is dependent on which kind of object you want to detect, but I want to detect footballs, so I just add my football label, and that's the only one I will use. All right, and I think now we can start labeling. Yeah, that looks good. So what we will do is I first click on the football, and then I will, yeah, create the bounding box. Can be more accurate, and oh, yeah, now the tedious work starts because I have to repeat it for 20 different footballs. You should do the same for your individual class you want to detect. And yeah, I will do that now. And okay, I have now labeled all my 20 football images. What I forgot to mention before, what kind of scared me, after you have labeled your image, make sure that you click the submit button. I forgot that for all of them and got scared that all my annotations or labels were deleted afterwards, but luckily they were still stored. But make sure that you press the submit button. Now I only can update. And you can see, since I only have one football per image, now in every image I have one annotation. So that's perfect. So they look like this, to just show a few. And now what we're gonna do is to click on our project, like object detection, and export it here. Okay, and as it seems, we first have to create a snapshot, like in the local variant of Label Studio. I didn't have to do it, but let's see what we... Okay, I might just create snapshot. Let's see what happens. Okay, it's processing now. Now we can download it. This is like important to choose YOLO here, which is like the model. We will later, for the object detection, use the YOLO model. So we will also choose YOLO here. Okay, there it is. Now export it. This looks good. Yeah, and I tried it earlier. I had the same issue. For some reason, the images are not in this data set or exported in the cloud variant of Label Studio. When I tried it locally on my computer, the images were definitely also exported. So I think this is now a tedious work because you can still see your ID, like of the individual images, which I had here. But now I have to copy those images into this image folder, and each time have to rename them to the particular ID Label Studio gave to that annotation or image, which is really annoying. I don't know why it is like that. I'm thinking right now if I should write a script for it or just do it by my own. Yeah, but I will quickly take this image, for example, put it in this image folder. And now we have to look up, it's this ID, so I just copy it, go back to the images. I do it like that, and now I have to do this process 20 times, which is kind of annoying, but like if somebody figures out how to also export the images from Label Studio, the cloud variation, please share it in the comments. I think others will also like to know it, which would save definitely some time. Okay. Now I renamed all those images to the particular or individual ID which was given by Label Studio. So the IDs or names of the images match the ones from the labels we have here. So what we will do now is we don't need the classes text file and also not the nodes JSON file. So we only need the images or images folder and the labels folder. And now we will create two more folders, which will be the train folder and validation folder, which we just call val. And then we will create in the train folder also an images folder and labels folder. You can copy them and also insert them or paste them in the val folder. What we will do now is we take the first 16, we will now take the first 16 images, and it's like alphabetically sorted, so the same will be for the labels later. Take them. Okay, I copy them, I go to the train images and insert them to the training folder. Now we will do the same with the labels. Go here, labels, and then we will take the remaining 4 and put them in the validation or val folder. So that we have already our dataset split up into 2 different categories. So, usually you have like a distribution of train and validation from like 70 to 30 or 80 to 20. Now I choose like 80 to 20, so 80% of my images are training images, which are 16, and 20 are validation images, which are the 4 images we see right now. And yeah, you can also see the labels are identical. Now those are matching, and we have basically our data set, which can now be used to train the YOLO model to detect our custom object, which is the football. And since we split those 2 up, we can also delete now the images and labels folder. And finally, we can take those 2 folders and create a zip file out of it by using, where is it? Compress, sorry. Took me a little longer to find it. I'll just rename it to dataset, and then yeah, we have created our custom datasets, which we can now use to train our object detection model. Okay, now that we have our custom dataset, let's get started. Let's train our YOLO model. As you can see, it's the version 7 of the YOLO model we will use for the object detection model. And yeah, first we will clone the repository from GitHub, which will be done by executing this cell. So we just cloning the repository and changing the directory. So we're just jumping into the YOLOv7 folder. Next we will upload our dataset. So yeah, I just drag and drop it here. So it will be uploaded. Okay, and now that the dataset is uploaded, we will unzip it using this command. So we can refresh and see it's unzipped now. Also open it up. So, and the next step would be already to train the model, but we need a little bit of preparation beforehand. You can see our data. We have like the Coca YAML file, and that we have to slightly adopt. So we jump into the data folder inside the YOLOv7, download the Coca YAML file. Then I will just open it using text edit. Feel free or use whatever text editor you like to use for that. It's not that much that we have to do. So you can see this is like a default setup. We just have one class right now, which would be for me the football. Make sure it's matching the exact same label or text you used in the label studio for annotating all your objects. Then we also have just one number of classes, like here. This we can remove, we don't need that. And now maybe you remember we have like a train and a val folder, but we don't have a test folder, so we can also remove this part. And then if we remember, we're basically jumping into the YOLOv7 folder inside here. So we have to jump out of this into this level, and then we have our actual data in the data set and train, and inside train and validation we have each time images folder where our images are inside. So that's also what's stated here. There are 3 different options. We basically went for this one, like path and images. So we will jump outside, go then to dataset, train, images. So that's our first one, and then we basically can copy the whole path, just replace the train. So this is how your Cocoa YAML file should look like. I will, unfortunately I did already here, so I have to rename it. And now I can upload it again. I'll just drop it inside the dataset folder. Also make sure that it's inside here. So we have the following structure. Inside the dataset folder, we have the Cocoa YAML file, which then is exactly how it's stated in this statement. And everything else we can leave like it is. And yeah, now we can just execute this cell. This will take a while. Could be, especially like depending on the batch size, but also in this, in this configuration file, it stated that we will train for 300 epochs, which will definitely take some time. So yeah, maybe grab a coffee and yeah, take a break, whatever. Okay, unfortunately, it didn't work as I was hoping to work. So there was a small failure, like runtime error indices should be either on CPU or on the same device as index tensor, and I found that there's an open issue for that, and there's a solution. Unfortunately, it hasn't been fixed in the YOLOv7 repository, so hopefully when you will check out the repository, it's already fixed, so you don't have to care about it. But if you happen to run into the same error, just follow what I'm doing right now. So we have to alter the loss py file at line 742. So let's do that. Let's jump into YOLOv7. Then we have utils, the loss file. We go to 742, line 742, and just select that and replace it. So we just added basically the device equals CPU here. Make sure to save it, to place like to type in command S to save the file, and then you can just execute the cell again, and this time definitely make your coffee break, because now it should work. Okay, and now our model is trained after 299 or 300 epochs. It actually didn't take too long, to be honest. I was expecting it to take a little bit longer. So the last model is saved under this path, and the best performing model is on, saved under this path. So just, the file name is actually different. So let's look into it. We have our YOLOv7, then runs train YOLOv72. Yes, and here we have different training results, but actually what I was about to look for are the weights, which we have inside here. So this storage is only existing in our current runtime, but if we would close the Colab Notebook, the runtime, and hence also our model path, or like the weights, wouldn't exist anymore. So in case you want to reuse your model, make sure to download it, definitely, so you can upload it later on again. Because otherwise your model would be lost. But we can either check one of those pictures, which already looks really good, as we can see. In case you want to monitor how the training is developing, how the convergence is of the model, you can run this command. It's not mandatory to be able to detect afterwards. Just, for example, if we look now not into metrics, into our validation, we can see that there's still some convergence, and maybe if we would train longer than 300 epochs, it could, even decrease the box loss. Maybe another run could lead even to better results. It's just a guess at this point. But let's move on, and because I promise you, at the end you will be able to have a final model with which you can just detect your object in whatever image or video you have. So first we would take the path we got here. So we have runs and place it in here. So this is like each time new generated. Because of that I made this placeholder here. Yeah, make sure that you fill it in the way that it fits, like that the path actually is true. And then we just need a source image. For that I would just go to our data set. Then we will use well images. And let's just go for this option. And now that's the image I used. Let's see how good our model works, how good the detection result is. Definitely you can also upload like a video here. So there are different source types possible. So not just only images, but also videos, just so that you know. So basically what you need here is once the weights of your model, your confidence interval. So in case you feel like, you know, your model is detecting objects which are actually not an object, maybe increase this value. So the probability or the amount of detected boxes will be decreased by that, the higher the confidence is. And yeah, here's just the source for which you would like to get in, would like your model to detect objects in. And now we can see it, the detection result is saved under runs detect. So let's look into that. Runs detect. Okay. And as you can see, this is quite, we just gave the model 16 training images, and this is actually really good. So you can see here's a larger margin, which would be ideally a little bit closer to the ball. This, in my point of view, perfect. This as well. And here it's also a little bit too small, cutting the ball at this part here. But overall, I think this is, especially considering that we only had 16 training images, a really great result. Share in the comments with me what you think about YOLOv7, how good it performs even with low data. And yeah, also feel free to share what kind of objects you were about to detect. I'm always keen and happy to hear your stories, how well it worked for you. If you have questions, you know, share with me. I'm happy to help, and yeah, just want to know what you're using those object detection models for. And that's it for today's video. I hope you got great detection results. If so, give this video a thumbs up, subscribe to my channel if you like the videos I'm creating. And yeah, if you would like to learn more how those object detection models actually work, I can also make a video about that. Just write a comment below, and have a great time until then, and see you in the next video. Bye bye.